Hello everyone. So for today's class, I will be teaching circular motion and rotation. So following illustration shows that the diagram of circle shape. So before we deep dive into today's topic, I'm going to teach you the equation that we will be dealing with. The first equation is average angular velocity, omega. So the way that we use equation is it's delta theta over delta t. So I think you guys might familiar with this equation, which is associated with velocity, uh, displacement over time. It is essentially almost the same, just that the displacement replaced with the angle and then over time. So this is the travel angle from initial theta 1 to theta 2, and this will be the radius of the circle. And for initial time will be t1 from the first start of where will be its travel and will be final destination on t2. So that is essentially on the first equation that you will be dealing with, and I'm just going to put the arc equation. How do you find arc of the circle? So arc essentially is the radius multiplied with angle. That's it. Moving on to instantaneous angular velocity. So what is instantaneous? When the speed of an object is constantly changing, the instantaneous speed is the speed of an object of a particular moment, which is instant in time. So also same with the traditional kinematic equation, just that change from x travel distance to theta. And then for the average angular acceleration, which is alpha, will be the difference between the angular velocity divided by the time. So might as well, you guys familiar with acceleration, velocity over time, which is essentially the same. But from velocity, we are going to use the angular velocity over time. So the unit we'll be using for angular acceleration will be radian per second square, and then for angular velocity will be radian per second. You guys have to be really careful on the units because some question they need radian per second, or some question might need you to use revolution per minute. So you have to be careful on that. Moving on. So this is what I meant between comparison on translational motion and rotational motion. X, you guys have know it's the travel distance, and the theta is the angle. V is the velocity, and omega will be angular velocity. A will be acceleration, and the alpha will be angular acceleration. So I think you guys might be familiar with this equation. So these parameters essentially just change to the rotational motion. So it will be basically the same with the classical mechanic motion. All right. So let us understand the relationship between angular and linear quantities. We know that velocity is the difference between the time travels over the difference between the time, and then so in this particular topic, we want this is we imagine this is a side of the circle, the arc, and AT stands for acceleration on tangent, going sideways like this, and AR, which means the radial or centripetal acceleration, going this way. So the equation that we will use for acceleration in tangent will be r times by alpha, and the radial or centripetal acceleration will be using r times by omega square. If you guys want to find the total of the acceleration between the tangent and centripetal acceleration, it is essentially using the basic math. So you just use this equation, a a for acceleration on tangent force plus acceleration on the centripetal square, and then you have to square root it. And after that, this is the final form of equation. So you have to factor the r here. And then, so what's left will be a square plus w times power of 4 square root, right? Okay, I hope that you guys understand what I'm trying to teach on this topic. So to make you guys better on this topic, I'm going to give a few example and problem, and we discuss on the solution together. So on the first example, it shows that a wheel rotates with constant angular acceleration of 3.5 radian per second square. If the angular velocity of the wheel is 2 radian per second at t time equal to 0 second, what angle does the wheel rotate through in 2 seconds? And what is the angular velocity at t equal to 2 seconds? So what I usually do is I will extract what information that given by the question itself. So write it down. Given. So it says that the angular acceleration is 3.5 radian per second square, and then the angular velocity omega will be 2.0 radian square, and then it says at t equal to 0. So after you extract the information given by the question, so we can basically solve the following question. So a question 1 to ask us to solve the angle rotates through in 2 seconds. So we want to find the angle. What is angle? So the angle that because it gives the info alpha and omega, so we want to find the angle. This will be equation that I'll be using because it have theta in the equation, and we have this vital information that we need to solve the equation. All right, and let's solve it together. Theta naught, the initial value of theta, and then omega naught times by t plus half alpha times by t power of 2. All right, so we need to solve for theta. Initial value of theta will be 0 because it begin in 0, right? And plus the initial value of angular velocity, because it says that at t equal to 0, so we assume that it begins at t equal to 0. This will be initial, so let's put that in. And then t, because it says that in 2 seconds, right? So we just put 2 seconds there, plus 1 over 2. And acceleration, we already have it, 3.5 radian per second square, multiplies by 2 seconds square. All right. So basically this will be 11 radian. So we already solved for A. It's quite simple. Let's move to question B. It says that what is the angular velocity at t equal to 2 seconds? So it says that angular velocity, right, at t equal to 2 seconds. So we go back to the equation what we want to use. So we identify all the parameters that we know so far, and we know that the initial velocity w naught will be omega naught, 2.0 radian per second, and the angular acceleration will be 3.5 radian per second square, and then we also have the time, which is the question wants us to solve at 2 seconds. All right, so I think the most sensible equation that I'll be pick will be the first one. All right. So omega equal to omega naught plus alpha time 2 radian per second for the first speed, and the acceleration will be 3.5 seconds square, and then the time says that it needs 2 seconds. So the answer will be 9 radian per second square. No, because it is velocity, the angular velocity, so we already find both of the answer. So I hope that this example will show you the basic understanding of in this topic. So I think we can move to the second problem. So it says that a record player rotates initially at a rate of 33 revolutions per minute and takes 20 seconds to come to rest. So A, what is the angular acceleration of record player? B, how many rotations does the player make before coming to rest? And C, what are the magnitude of the radial and tangent components of the linear acceleration of the point at t equal to 0? So the given radius is 14 centimeter. So like what I said in the previous question, extract what information that you know based on the question itself. So the given information, 33 rev per minute. All right, and then t equal to 20 to rest. So A says that what is the angular acceleration of the record player? So we know that the equation of acceleration itself is velocity divided by time. So in circular motion, it's alpha equal to omega over time. So it gives gave us the initial rate of 33 revolution per minute, but however the unit is revolution per minute. So because usually in this topic we usually convert it to radian instead of revolution or RPM. Suit yourself. It's dependent question. If the question asks you to convert, you convert. If the question doesn't want you to convert, you don't need to burden yourself. So right now I'm going to teach you how to convert from RPM to rad. All right. So 60 over 2 pi RPM is equal to 1 radian. So if 33 RPM, how many radians? How do we convert it? Just cross multiply. So 33 RPM times by 1 rad over 60 2 pi RPM. So this one just cross. All right, so will be 3.46 rad. All right, we just key in what's the information that we know. So sorry about that. Final minus initial, t final, t initial. So they don't give the final velocities. So it will be 0 minus 3.46 radian over, because t is 20, right? 20 minus 0 will be 20. So the final answer will be negative 0.70 radian per second square, because seconds you can multiply each other in a minute square. So negative in front of the answer shows that it is slowing down. Don't worry about the negative on the answer. So let's move on to the B question. how many rotation does the player makes before coming to rest? How many rotation? So rotation is how does it travel? So travel associated with the data. So the equation that we will be using is this one. All right, just going to copy that. So we want to find theta, right? So theta initial was 0 plus we got this one, initial rate of 33 revolution per minute, already converted to radian, and we just plugged it in. 3.46 radian multiply with time, which is 20 seconds. All right, 20 seconds plus half, and then the acceleration will be negative 0.17 radian per second square multiply with 20 seconds square. All right, so the answer will be 35.2 radian. So we got the answer. Actually, you can leave it 35.2 radian because the question doesn't require you to convert it, but because I want to teach you how to convert, right, I'm going to convert it anyway. All right, so 2 pi radian equal to one revolution. So we got the answer 35.2 radian. So how many revolution? So we just cross multiply like what we did this one. So the answer will be 5.60 revolution. So just simple as that. The final question is, what are the magnitude of radial and tangent components of the linear acceleration of the point at t equal to 0? The radius is for 14 centimeter. So let's get back to the previous slide. So we want radial or centripetal acceleration. So we are going to use this equation, all right? And then we also want to find the tangent of acceleration. Also, we are going to use this equation. The question gave us 14 centimeter. Usually I convert it to meter because it's better to see the speed in velocities meter per second, or acceleration meter per second square instead of centimeter per second square, you know. All right, we know that for C we wanted to find the tangent acceleration. So the question that we are going to use will be radius times by the acceleration that we find just now. So the radius is 14 centimeter, convert to meter will be 0.14, and then we already counted for the acceleration here. All right, so we're just going to plug that in from the previous question. Final answer will be 0.024 meter per second square. All right, wonderful. So the final question asks for the radial acceleration. So radius times by omega square. So the radius it's given there, which is 14 centimeter, convert to meter, which is 0.14 meter, and then the initial rate, which is we already converted from 33 revolution to minute. So the initial angular velocity will be 3.46 radian. All right, 3.46 power of 2. So the final answer will be 1.68 meter per second square. So I hope you guys understand for today's topic, and if you guys have any question, just ask away. So I think that's for today's topic. Thank you.